This video is going to do 2 extra examples on simplifying radical expressions. So I'm going to take my notes. I'm actually going to go to the back page of this and write down 2 other examples just to make sure you can simplify just the variables themselves. So this is extra practice. Extra practice. So number 1 is going to be the square root x cubed y to the 7th z to the 13th. We're just going to simplify this. Okay? So because there is no number inside your index, that means that that value is a 2. So you got to remember that if you don't see a number there, that has to be a 2 because it's called a square root. And when you square root something, you have a 2. So again, we're going to separate these into you have an x, a y, and a z. So we're going to do 3 different parts. So the first part is your x's. You take your index, and it goes into your exponent for the 3. Now, 2 goes into 3 one time with the remainder of 1. What that means is that you're left with an x raised to the first power as your coefficient. We have the square root still of x raised to the first power in your radicand. Then we'll go to, so then that one is finished. Then we'll go to our y's. So again, our index is 2, divides into the exponent for the y is 7. 2 goes into 7 3 times with the remainder of 1. So because 3 times 2 is 6, you subtract, you get 1. That means that you have y to the 3rd power as your coefficient. Since we still have a remainder, we have to have our square root. So again, that's the square root. And then we have a y raised to the first power in our radicand. And then that's so we have a 3, our 1, and we still have our square root, because whatever this number is, what you divided by, is still your index. And the last one we have is that z. Now again, our index is 2 still, goes into 13. 2 goes into 13 6 times with the remainder of 1. That means we have z for the coefficient, z to the 6th power. Since we will have a radicand left over, we have to put that square root of z to the first power in our radicand. Since we have done all the letters, we can go to our final answer. Take all of your coefficients and put them together. So it's x to the first, y cubed, and z to the 6th. X, y cubed, z to the 6th. X to the first, y cubed, z to the 6th. We do have a radical. Even if we only have one radical left over, we have to put that radical symbol. So that square root. Again, radical is any type of root. This is specifically a square root because the index is 2. All of your radicands. X to the first, y to the first, z to the first. We just write them all in here. X to the first, y to the first, z to the first. Now, this is still technically a square root, even though I don't have the number there. Remember, if you don't see a number, that is a square root. And it was a square root. All of these are square roots. I just have to make sure that my roots are the same throughout the entire problem. And that's our answer. The next example I'm going to do is going to be the 4th root. Now notice that my 4 is inside this little nook. It's not on the outside of the problem. You got to be very careful about that. This number is inside that little nook. So I make sure I'm very careful about that. A to the 7th, B to the 12th, C to the 2nd, and D to the 623rd. I wanted to give you a large number in there because I want to show you how to make sure you can do that. So we have no numbers as our radicands, so we don't have to simplify numbers. We won't get any decimals. We just have letters. So again, we separate the letters. We do A first. Now our index this time is a 4, so we do 4 goes into the A is raised to the 7th. That's where we write out what letter we have so that we can stay organized with it. 4 goes into 7 one time with the remainder of 3. So what that means is that we have a to the first as our coefficient. If we have a remainder, that means we have to have a radical. Now this is an index of 4, so I have to keep my fourth root in my problem the entire time. This is a to the third power as our radicand. And that's the end of A. Now I go to B. B. Again, our index is 4. Goes into 12. So 4 goes into 12 3 times with the remainder of 0. So what that means is we have B raised to the third power as our coefficient. We have no remainder, so that means I do not have a radicand for the B. The C, our index is 4, goes into our exponent of C is 2. 4 goes into 2, it does not go into 2, so it goes in 0 times. So 0 times 4 is 0 times 4 is 0, and 2 minus 0 is 2, so the remainder is still 2. If your index is bigger than your radicand, your exponent of your radicand, you can't do anything with it. So that means that your exponent and your radicand is still the same. So what that means is that we do not have a coefficient, but we do have a radicand. See, after the r is your radicand. So this is the fourth root, don't forget your fourth root, of c to the second power. And then the last one is the letter D. So our index again is 4, goes into 623. Sorry, 623. I accidentally put 628. I will fix that real quick. 623. Now, I don't want to actually do the entire long division process. We can, but I'm just going to get my whole number from here, my calculator. So I have 623 divided by 4. I want my whole number, 155. So I know that 4 goes in 623 150 times, 55 times, with a remainder, because I have a decimal. So what I want to do is just figure out what my remainder is. So 155 times 4 gives me 620. So I subtract, and that's where we get 3. So our remainder is 3. What that means is we have a coefficient exponent. So we have D raised to the 155. We have a 3 remaining, so we have a radicand. So we have the fourth root of D raised to the third power. That's all of our letters, so now we can go back and write our final answer. We have no numbers in here, so no actual values, we just have letters. So we get all of our coefficients. So a to the first is a coefficient. B to the third is a coefficient because it's outside of the radical. C does not have a coefficient. D has a coefficient of D to the 155. Then we look for our radicands. If we have any radical at all, that means we have to have a radical with our index. Our index was 4. It's remained 4 throughout the entire problem. So we got to make sure it's fourth. Fourth root of. Now all of your radicands. A has a radicand of a cubed. B does not have a radicand because there's no radical. C has a radicand of c squared. And D has a radicand of d cubed. So this is our simplified version of the fourth root of a to the 7th, b to the 12th, c to the 2nd, and d to the 623rd. Again, this was just to show you for the letters, another 2 examples of making sure that you keep your indexes throughout the entire problem. Make sure you know how to simplify letters even when they have very large numbers, that you still can do that.